along with that, you will be having fundamentals of mathematics and something related with the English, like your communication, how it needs to go. All these also will be included during this bridge course program. So be regular to the classes and also let your other friends who are willing to be also to be into the program. It's not that if they have taken the admission here only are allowed. If anyone else is interested also, they can join with. We just wanted to serve the student community. Okay. So we have a good faculty over here. While you were taking the admission, you would have been given a brief out even about your programs that are available, everything to be given for you people. So be particular that you have the best resources to be available with Spurti Engineering College, and that would be provided from our end in the best way. And you can trust that definitely it is a place where you can have the good career to be built in. So to start with, we will be having here the day one. We are going to start with the programming subject, which is being taken over by Ram Mohan sir. Sir is having about 10 years of experience with the same organization. Apart from his 20 years of complete professional experience, he is very good at other subjects. No, it's that the basics he is giving you now, but he is very good at the other emerging technology groups, etc. So all this will be helping you people to cope up with and also have easily accommodating whatever the content you will be having in the regular curriculum. Sir is also a good resource person. Generally, he just takes out the classes in emerging technologies as with the different organizations. So we are giving the best for you and hope this will be definitely helping you all. Okay. Nandini, were you having the whole content to be given in a clear way? Were you able to get it?
Yeah, chat is enabled, madam. They can type in the chat box.
Yeah, ma'am. If you are clear with, you can just put a message in the chat box, ma'am. You can post a message in the chat box. First, you people need to be little active now. Only once you are active, we can know how far it is reaching you. It shouldn't be just a blind plus that we keep talking on our own. It simply reflects that we are talking to ourselves.
Yeah, they are responding. Yes.
Yeah. Yeah. Thank you, Alma. Thank you, Ramohan sir, for initiating this on the day one. Thank you very much. Over to you, sir.
Yes, madam. Thank you. Thank you for the wonderful introduction. So we will start today's session, madam. Yeah.
Yes, sir. You can continue it.
Yeah. Yeah. Good morning, everyone. So I hope I am audible, and let me share my screen before we begin. So can you see my screen? Anyone just type in the chat box?
Yes, it's
Yeah,
visible,
done.
sir.
Yeah, yeah. Thank you. Thank you. So friends, welcome you all to Spurti Engineering College. And as part of this bridge program, we will be teaching you something called as Introduction to Computing. So before we move on, let me tell you very clearly what is the purpose of doing a bridge program for you. As head of the department, Dr. Gayatri Madam has already mentioned, like there is a gap of around 2 to 2.5 months before you actually get into your engineering program. So in order to fill that gap, and another important point is to give you the fundamentals of computing. So what is the objective of this bridge course, especially in computing? Apart from computing, I think as ma'am suggested, there will be bridge program in mathematics and even communication skills, I believe. So coming to the objective of bridge program in computing. So the purpose is we wanted to emphasize the importance of computing, programming, and problem solving. So these are the three things everyone need to understand its importance, irrespective of your branch, whether you are from computer science engineering, AI, ML, data science, cyber security, ECE, or civil engineering. For every engineer, this is required. So, irrespective of your branch, it is mandatory that everyone understands what is computing and what is programming, and of course, the importance of problem solving. And irrespective of your branch, when you start your engineering program in any branch, the very first semester, you will be taught one programming paper. So whether you are from a civil engineering background, electronics, or any other branch or a computer science, programming is mandatory for everyone, right? You know very well every engineer and everywhere people are using computers, people are using software. So you can't say software and programming are something related to only computer science and other related allied branches of computer science. So today, every day is everyone is working through software enabled applications. So everyone needs to have some understanding of programming, and problem solving is one important skill which every engineer must possess. So the objective is to emphasize the importance of computing, programming, and problem solving. And in this journey, when you start your programming journey, probably after 2.5 months, before you actually begin, we wanted to impart the foundational concepts of computers, computing, and basic programming foundations so that it will help you in your programming practice down the line in your first year, first semester. So programming and problem solving are two unavoidable, very, very important skills which every engineer need to have. And for that particular programming practice and problem solving, we wanted to give you the fundamentals. So these fundamental classes which you are attending as part of bridge program, they are very, very, very important. They are not only useful for you in your first year programming practice, but also down the line in your second, third, and final year also, you come across various engineering subjects in which these fundamentals will play a critical role. And hence, it's very, very important for you to understand the importance of these preliminary classes, foundational classes on computers, foundational aspects of programming, and problem solving. So I hope you got a fair understanding of why we are doing a bridge course in computing. Similarly, you will have some bridge programming, mathematics, and even communication skills. But the purpose and objective of bridge course in computing, I hope it is clear. So what exactly we are going to discuss, right, as part of this particular bridge program. So we begin with something called as what is computing and what is the need for computing. Then we try to understand what is programming and why it is required, right? So before we get into the details of programming, like which actually starts after 2.5 months, we need to understand what is a computer. Basically, what exactly is a computer and what are the functional units of a computer. And the most important concept in the entire bridge program is memory. Understanding memory is a very, very important aspect. So I'm not talking about the topics which we are discussing today. I'm talking about the entire bridge program. So entire bridge program will be focused on these aspects. So what is the importance of computing? What do you mean by programming? Importance of programming. And before that, one need to understand what is a computer, functional units of a computer, and of course the memory. So before we move on, we start our course. Please let me know whether the purpose of the course and objective of the bridge course was clear to you or not. Kindly respond in the chat box. Yeah. And even if you have any doubts, please don't hesitate to type in the chat box, right? Regularly after every topic, I'll ask you whether the concept is clear or not. And at that time, kindly don't hesitate to ask. If you don't understand, kindly text me in the chat box that sir, so and so concept is not clear. Probably, we can discuss it again, not an issue, right? So that's great. People are responding, and now we will move on. So, what is computing? Computer is a word which is quite common. Everyone knows this word. Everyone is using computer these days. So, computer is not a very, strange thing for anyone. Computer is a very, very common device, right? It's part of everyone's house now. It's a domestic thing, right? So computer is not new for us, but what do you mean by computing? This is a very, very important point, important concept. So computing is the use, study of operations of computers, how computers work to process data, manage the information, and perform mathematical or logical operations. So what is computing? Computing is a very big subject actually, wherein we try to understand how computers work, how computers manage data, how computers perform mathematical and logical operations. So that is computing. And on computing alone, you will be studying 4 to 5 different subjects in 4 year engineering program, especially people who belong to computer science, artificial intelligence, data science, and cyber security branches. So computing is a very, very important aspect. So we will not discuss entire computing and various types of computing in our bridge program, but we just wanted to define what is computing and why it is important. So what is computing? Computing means computing is a study wherein we try to understand how computers process the information, how computers perform mathematical or logical operations. So that is computing. Computing is very, very important. Need for programming. So when you join your first year, first semester, you will be taught a programming paper, programming for problem solving. So today we are trying to understand and we are trying to answer a question called as need for programming. Why do we need programming? Not only for programming paper, my dear friends, you need to ask questions, right? If you really want to understand concepts in engineering, if you really want to learn engineering properly, two things you have to remember, not only in this subject, in every subject, two important things you need to remember. Point number one, for every topic, you need to ask why I should learn this topic, where this will be useful. So questioning is one very, very, very important quality of an engineering student. In fact, for every student, it is applicable. So you need to question. And the second important point is you need to practice. Engineering is not studying. Engineering is not learning, sir. Engineering is doing things. So whatever concepts we discuss, right, you need to practice. Suppose in programming subject, today we discussed the topic and we solved one problem. Same day you need to solve another 4 or 5 problems on the same topic. Of course, we will give you the references from where you can get the questions. So engineering is all about doing. Whether I teach you a subject or any other professor teaches the subject, what we can do is we can only introduce a concept to you and we can solve 1 or 2 problems on it, and you will get experience, you will get mastery in the concept only through practice. So suppose I solved 2 problems, you need to solve another 2 on the same day. And if you face any difficulty, you need to come back and ask questions in the class. So if you don't have these two skills of or these two qualities of asking questions and practicing things, then remember you are going to waste your 4 years of very, very precious time and money in this engineering program. So these are the two things which you should possess. These are the two qualities which you should possess. Now, before we move on, need for programming. So this is something which should be a question from your end. So why are you teaching us programming? Why do we need programming? So this is a very, very important concept, and we try to understand this concept today, the need for programming. Yeah. So what I'll do is I'll be unmuting couple of students or maybe one student. Uh, Nandini was available in the beginning, so I will unmute her. Nandini, I hope you can speak out now, right? Your mic
Yes, sir.
is permitted. Yeah.
Yes, sir.
Now, all other students, please observe the conversation between me and Nandini. I'll be asking some questions to Nandini, and I want Nandini to answer these questions quickly. It's like a rapid fire round. Okay. And
Okay,
don't
sir.
worry, Nandini, it's not, very tough thing. And I know what will happen when I ask you questions and what kind of answers I can expect. So I'll be asking you questions and I'll expect you to give answers quickly, right? And
Okay,
there is
sir.
an important reason why we are doing this activity. So I want all others to observe carefully the conversation or the question and answer activity which is happening between me and Nandini. Nandini, I'll be asking you questions, right?
Okay, sir.
It is nothing but tables, my dear. Okay, tables. What is 4 into 2?
What is the 8, sir?
That's great. 2 threes are
2 3s are 6.
okay. 6 twos are
6 2s are 12.
12 fours are
12 4s are 48.
48. 13 sevens are
13 7s are 91.
that's great. Then 19 nines are
19 9s are 171.
excellent, Nandini, excellent. 1340 into 1596.
1300
40 and 1596. So you need little time, right?
yes,
You need
sir.
little time? Yes. So
Yes,
that's
sir.
it, Nandini. Thank you. Thank you very much. Now I wanted everyone to observe our conversation and I hope everyone was with us. So did you notice when I was asking her what is the product of 2 by 3, I got answer quickly. 4 twos, I got answer quickly. And even 19 nines, I'm happy that I got answer quickly. But what did you notice? As the size of the number increases, what will happen is the time taken to give the answer will also increase. And the moment I said some 1340 to 1596, nobody can give me immediate answer. Even you ask me the same question, even I can't give you the answer immediately. Probably you give me pen and paper, and I may take some time and I can give you the answer. Right? So do you all agree with me that when the size of the number was increasing, the time taken to solve that problem will also increase? If you agree with me, simply type yes in the chat box. Yeah, people are responding. Yes, it is true that as the size of the number increases, definitely we need some time. Now, another important point, which again I want your response. The other important point is instead of asking, 4 twos are 12 fours are, if I start asking you like 3-digit numbers, 4-digit numbers, 1340 into 1596, 4096 into 1230. If I start asking you such big products, let us say 10 times, 12 times, There is a chance that 1 or 2 times even we can commit a mistake, even with pen and paper also. There is a chance that we can commit a mistake. Do you agree with me? Do you agree with me that there is a chance that at least one time there is a chance that we may commit a mistake? At the end of the day, we are humans and we may commit a mistake. So do you agree with me? Sai says yes. Yeah. Lakshmi Prasanna Tanushree. Yeah. So you people are agreeing on two things now, which are facts. Point number one, right? As a humans, right, we have two challenges. As the size of the problem increases, we may need more time to solve the problem. And when we start solving such big problems, there is a chance that we may commit mistakes also. Now, let me ask you one more question. Suppose if I use a computer, right, or even a calculator. If I use a computer and if I have developed a program to find product of two numbers, let us say. Now, what will happen instead of Nandini answering the questions or instead of Ram Mohan sir answering the questions, if there is a computer program developed for finding product of two numbers, now tell me, what will happen when I give two numbers of any size? Whether it is a 2-digit number or a 3-digit number or a 4-digit number, I'll get the answer immediately. Yes or no? I'll get the answer immediately. It will ask you enter first number, enter second number. Then you press enter, immediately it will give you the answer. So do you all agree with me that if it is a computer program, it will not say the number is too big, so I need some more time. It will give you answer immediately, right? So the final conclusion is, computers are fast and accurate than us because computer will not do a mistake. No, when once the program is written properly, whether you ask the product of 19 into 9 or 19 into 999, it will give you the answer in same time, and of course it will give you the correct answer. So based on this, can we conclude like computers are fast and accurate than humans? So if you agree on this one, then we can continue our discussion. So do you really agree that forget about computer, even in calculator, we can notice that, right? Computer is more powerful than a calculator. In calculator itself, we have seen how quickly it will give you answers. And obviously, have you ever seen calculator giving you a wrong answer? So computers are more fast and accurate than us. So that is the conclusion, my dear friends. So why we are discussing this? Why we took an example where we started asking questions to a student and we have seen the difficulty. Same is the difficulty which everyone will face, whether it is you or me. Even you ask me what is product of two 4-digit numbers, I can't give you answer immediately. You know that. Whereas if it is a computer, it gives you answer immediately and without any error. So final conclusion is computers are fast and accurate than us. Computers are fast and accurate than us. So don't we prefer to use computer? Since computer is fast and accurate, obviously I want to use computer for my day-to-day activities. Do you agree with me? We want to use computer or not? When computers are fast and accurate than us, then obviously I want to use computer for my day-to-day activities, right? So you all agree that computers are fast and accurate, which is absolutely true. And you also agree that computers are fast and accurate, and hence we want to use computer for our day-to-day operations. You all agree with that? That is a great point. and that is the conclusion. Now coming back to our slide from where we switched to our example. Need for programming. So why do we need programming? The reason why we need programming is we just now concluded like computers are fast and accurate. When computers are fast and accurate, then I want to use computer for my day-to-day activities. Now, in order to use computer for my day-to-day activities, how do I instruct computer? How do I give instructions to computer? So how do I give instruction to computer? Can I ask the way I was asking questions to a student? Can I ask like that for everything? No. So in order to give instructions to computer, you have to give the instruction in a language which computer understands. Okay. Now the point is, what is the language that computer can understand? This is a very important point. This is a very important slide. This is a very, very important session, right? Which is a very, very, very crucial discussion. And for all your entire programming journey down the line, this will play a crucial role. So please be focused, right? Please pay attention and try to understand. So computers are fast and accurate. We have concluded, and we wanted to use the computer because it is fast and accurate. When it performs better than us, obviously we want to use. But the problem is computer is an electronic device. Please remember, computer is an electronic device. There is a separate subject called as computer organization, which every one of you will study in second year, wherein in detail you will be taught what are the various components of computer and how they talk to each other. All those things will be taught in detail in a separate subject. But for now, the point to be noted is computer is an electronic device. Computer is an electronic device. So what? Okay, it's an electronic device. So what? Computer is an electronic device and hence it can't understand anything apart from ones and zeros. In fact, computer can't even understand ones and zeros. It's an electronic device. It can only sense two things: presence of voltage, absence of voltage. Presence of voltage is treated as 1, absence of voltage is treated as 0. So what computer will understand is it's an electronic device. It can only sense two things: presence of voltage and its absence. And based on that, presence of voltage is treated as 1, absence is treated as 0. And based on that, instructions are formed using sequence of ones and zeros. What do you mean by this? What do you mean by this? The meaning is, for example, you know how to write a 5, number 5, numerical 5, we know how to write. In computer, 5 will also be written using binary code, means ones and zeros. Binary means only two digits are there, 1 and 0. So using a binary sequence of ones and zeros, 5 will be represented. Suppose if you wanted to write hello, even hello means alphabets, H is there. For H, there will be a binary sequence, right? Means for data, whatever data is there, it should be represented in binary sequence. And whatever instruction is there, for example, you wanted to say addition, plus symbol is for addition. We all use plus symbol for addition. But computer can't understand the plus symbol. For addition also, there will be a binary code. Like that, for every data and for every instruction, computer uses binary sequences. Now the problem is, can I use this binary codes? How many binary codes we can remember? For A, there is a binary code. For B, there is a binary code. Like that, for every alphabet, there is a binary code. For every symbol, there is a binary code. For every number, there is a binary code. And for every instruction, there is a binary code. So can we remember lakhs and lakhs of binary codes? Impossible. So when I can't remember binary codes, can I give instruction to computer? Not possible, because computer will understand only the binary codes. So what we will do is, we wanted to use computer because it is fast and accurate, but we can't use computer because we can't use the language of computer, which is binary language. For us, it is highly difficult to talk to computer in its language, right? So please try to understand, we cannot give instructions to computer using binary language which computer understands. Now again the question remains same. Okay, when I can't give instructions in binary codes because I can't remember these many binary codes, what I will do? You will take help of high level English like programming languages. You might have heard about programming languages like C, C++, Java, Python, etc., etc. 3000 plus programming languages are there. Every language has got its own speciality, its own application, right? Which probably you will study in detail in your programming journey down the line after 2.5 months. But the fundamental point to be noted is why I should learn programming, because you can't give instruction to computer in binary language, so you give instructions to computer using programming language. What are programming languages? Programming languages are similar to English. English has a grammar, right? We all know that English has got grammar. Similarly, programming languages also have got some rules and regulations, right? In English, we have rules and regulations. We call it as grammar, where to put a full stop, when to use a comma, when to use an exclamation, when to use a question mark. There are certain rules which we call it as grammar. Similarly, programming languages are also high level English like languages. Means for us it is easy to learn, for us it is easy to implement, for us it is easy to learn and implement. But when I give instructions to computer using any programming language, computer can't understand. So please try to understand, the problem is still there. You are giving instructions in programming language like C, C++ or Java, but your computer can't understand it. It's like, uh, suppose our Honorable Prime Minister Narendra Modi has visited our state and he is addressing a rally in a remote place in a village, and entire crowd which they only understand Telugu, and Narendra Modi understands only Hindi. He can speak only Hindi, let us say. Now, what Narendra Modi will do, he will speak only in Hindi. And you might have noticed there will be one local leader who will be translating the statements of Narendra Modi from Hindi to Telugu so that people will understand what the Prime Minister is saying. Similarly, we need a translator. So we can't directly write instructions in binary code, that is clear. So we write instructions in some English like languages like C, C++ or Java. And we convert those English like instructions. We convert those English like instructions into programming binary instructions. So we need a translator. The way Modi's speech was translated into Telugu. Similarly, I write instructions in C language or C++ or Java or Python, and there will be a translator which we generally call it as compiler. So the job of this translator is to convert your C language code into binary instructions so that the computer can understand and perform or execute those instructions. So finally, conclusion is, do we need programming or not? Yes, we need programming languages. Why we need programming? Because we can't directly instruct computer using binary language. It is difficult for us to talk to computer in its own language. So the language which machine can understand is binary language. We can't use that language. So we write instructions in programming languages, and these instructions will be converted back to binary form, and computer can execute those instructions. So till now, whatever we have discussed, to summarize what we have discussed till now, the two important points. Point one is computers are fast and accurate than us. That's the reason we want to use computer. Second point, how do we give instructions to computer? Because computer understands only language of ones and zeros, and for us it is difficult, and hence we use programming languages. So programming languages help us in writing instructions to computer, and those instructions are converted by compilers or interpreters, which are nothing but translators. They convert our instructions written in C language or C++ or any other language into binary form so that computer can understand those instructions. So what is the need for programming? Is it clear to everyone? Please let me know in the chat box, and don't hesitate to ask if you have any confusion. Quickly respond. Yeah, that's great. Right. Now you understood what is the need for programming. Let us move on and we will try to discuss, right? Programming, all those things, we will discuss, but where a program will run? Program will run in a computer. So do we know what exactly is a computer? So we need to understand the functional units of a computer. What are the main, most important components of a computer? So that we are trying to understand. I hope you are able to see the screen, right? The title is block diagram of a computer, right? Is it visible? Just confirm it. Block diagram of a computer. I was just sharing a window where I am trying to write something. That window is visible or not, let me know. Yeah, that's great. Thank you. Now, block diagram of a computer. So friends, please observe this. This is very, very important. Block diagram of a computer or a digital computer. This you might have seen in many places, even in your, if you are from CBSE background, maybe in your schooling, you might have seen this. But you will find a lot of diagrams which are misleading, which are not correct. So let me draw this diagram and explain you clearly what are the functional units of a computer. So there is something called as CPU, central processing unit, right? Which we call it as processor also. And you have something called as main memory. Main memory. Right? So this is very, very, very important. And if you observe, CPU has a direct interaction with main memory. And there are so many other devices, other peripherals connected to the computer, other input output devices or other peripherals. So let me draw this. IO device, IO means input output device, IO device 1, IO device 2. Like this, I can have any number of IO devices connected to the computer. There is no limit. You can have a keyboard, you can have monitor, you can have a printer connected to the computer, right? Any number of input output devices. Okay. Now the most important point to be noted is this one. Please observe this. These arrows which you are seeing, right? They are actually called as buses. You will study in detail about bus in computer organization, but please observe here. These IO devices are connected to the computer via main memory. So this is the block diagram. So please observe this blue color bus. It is called as external bus. Bus is nothing but a bunch of wires which carry information in the form of electric signals. So this blue color line is called as external bus, and this one is called as system bus. Friends, I am not going to discuss in detail about how a system bus is created. It's all bunch of wires, right? How external bus is maintained, all those things. That will be discussed in detail. There is a separate subject called as computer organization. But whatever is required for our programming journey, those fundamentals we will discuss in our bridge program. So please observe this diagram. So what are the fundamental components? CPU is one very important component and main memory. And there is a bus which connects CPU and main memory. And the most important point to be noted here is, did you notice anything? CPU is our processor, right? Processor means actually the component in the computer which will perform all your executions, right? The only worker inside the computer is the processor, CPU, right? If you buy a computer, you might have heard the word i3 processor, i5 processor, i7 processor, like that. CPU is the most important component, means every job, every program execution, every task given by you will be done by CPU, the most important component. And another important point to be noted from the diagram is, did you notice CPU is interacting only with the main memory directly? Did you see a direct arrow or a connection from CPU to any other device? There is no direct connection from any other IO device to CPU. If any other IO device wanted to share some data, share something with CPU, or if CPU has to give anything to IO device, it will be done via main memory. See here, from main memory, there is an arrow which connects to external bus. From external bus, it will go to appropriate IO device. So the only device which is connected directly to CPU is main memory. So couple of important points to be noted, right, from the diagram. This diagram itself is one separate subject, sir, as I said, but our focus is on the concepts which are required for programming practice. So point number 1, only worker in the computer is CPU, means any execution, anything. It can be running a C program, or it can be playing a audio video file, anything related to execution is done by CPU. CPU is also called as processor. Second important point, main memory. We will discuss in detail what is main memory, all those things. Main memory is only device connected directly to CPU. No other device can interact directly with CPU. So these are 3 important points which you need to observe from our block diagram. And why only main memory is directly connected to CPU? Why not other devices? So from second point, you will get one question. So why main memory is only device connected directly to CPU? And what is CPU? CPU is the central processing unit. So anything related to execution will be done by processor. So there is no other processor inside a machine. Generally, there will be one processor. We call it as CPU or processor. And no other device can interact directly with CPU. So if we answer the second question, the same answer will be applicable to third one. Because why it is interacting with only main memory? If I answer this, that it also covers the reason why it is not interacting with any other device directly. So this is the block diagram, my dear friends. This is very, very important block diagram, right? Whenever we are discussing any concept, if you have a habit of maintaining a running notes, taking notes of important points, it's a very good practice. Kindly follow that and remember whatever these topics which we discuss in the bridge course, they will be not only useful in your first year, they will be useful down the line in many other subjects in your second, third, and final year. So these concepts are very, very important. And we just started uh, the fundamental concept, that is block diagram of a computer. So we will discuss in detail about this one, and slowly we will try to relate this. We will try to understand what components of this particular diagram are related in our programming, why we need to understand this block diagram, and how it will be helpful in our programming. All those things we will discuss slowly, right? So we are not in a hurry, and we have a lot of time. In fact, we are trying to fill the gap. So we are not in a hurry. We discuss things slowly, topic by topic, and we expect you people, right, to give proper responses. Means if you have understood, you say it's clear. If it is not clear, if you have any ambiguity, confusion, or doubt, definitely in the chat box, please don't hesitate to ask. And as I said, once again, I'm reminding you, if you don't have the habit of questioning, and if you don't have the habit of practicing things, then without any doubt, I'm telling you, you are going to waste most important, precious 4 years of your time. Because if these two qualities are not there, you're not going to become a good engineering graduate. Fine. So this is block diagram. We will discuss, it is just an initiation. We will discuss in detail about how Our focus area is CPU and main memory. So what is our focus area? Because execution is done by CPU. So when I write a program, who will run my program? CPU will run my program. And program involves some data, right? So where data gets stored in the main memory. What is main memory? We will discuss in detail. So these are the two important concepts in which we are interested as of now for our programming practice. Remaining things will be discussed separately in a separate subject. So before we wind up, a quick summary. We have uh, seen the importance of computing. We have seen why programming is required. And we started discussing block diagram of a computer. So before we wind up, if you have any doubts, please let me know in the chat box. Please let me know in the chat box. Any doubts? If there are no doubts, same thing you can mention. Do you have any doubts? Say yes or no. If it is yes, then also type your question. Any doubts? There are no doubts, please let me know. You can type no. If you have any doubt, type yes and also type your doubt. Quickly respond, please. Raghu, you have any doubt? Yeah, about main memory. What is your doubt, Nandini? Means you wanted to understand what is main memory? Nandini, you were expressing some doubt. What is that? Explain about main memory, sir. Sir, why not CPU can't be used directly? Yeah, yeah. See, actually, these two things we have not yet discussed. Okay. We will discuss main memory separately. We have not yet discussed. We have just shown you the components. So what is main memory means? So first point, it will not do any execution, sir. So execution is only job of CPU. So main memory is not meant for execution, not meant for execution. Execution is the job of only CPU. So main memory is not meant for execution. Then what is the purpose of main memory? It is used to store the data required for executing our programs, for executing any program, right? And the point is, sir, why we don't connect CPU directly to other devices? That we will discuss, right? That we will discuss. And even main memory, we did not discuss main memory at all today. We have just shown you the components. We just highlighted that CPU and main memory are two very important components, and our interest is in CPU and main memory, right? So I have not even told you what is the purpose of main memory, but now I mentioned it is used to store data. Now, what exactly is main memory? What we will do with main memory? All those things we will discuss in our tomorrow's class. And in tomorrow's class, what will happen is our diagram will be only this much. Means we will focus only on this part, CPU and main memory. So we will have a elaborated discussion on these two components in our tomorrow's class. So is that okay, Nandini? And others also? Sir, if no IO device can interact directly with CPU, then how do we interrupts generated by IO devices reach the CPU? That's an excellent question. Who is this? Jashwant. So see, actually we wanted to discuss these things uh, not in day one session, but anyhow we are asking questions, so let me answer. The reason why CPU does not interact with all other devices, the reason is very, very simple, sir. Reason is CPU is a high speed electronic device, and other IO devices, they are not pure electronic devices. Some of them are electrical devices, some of them are electromagnetic devices, some of them are electromechanical devices. So what? So what? The reason is these electromagnetic, electromechanical, or electrical devices are very, very, very slow when compared to CPU, which is an electronic device. Now, what will happen when a very high speed device starts interacting with a very, very low speed device directly? What will happen? I'll tell you what will happen. For example, I can teach 100 points in 1 hour. My capacity is I can teach 100 points in 1 hour. Imagine you people can receive only 10 points in 1 hour. Means my capacity is 100 points per hour. Your capacity is 10 points per hour. Then what will happen if both of us start communicating at our own speeds? Means every day I'll come, I'll log in and I'll teach 100 points because I can teach 100 points. But you people can't understand more than 10 points in an hour. So what will happen, sir, if I daily come, if I teach 100 points every day, you will be receiving only 10 points per day. Do you think that communication is useful? It is not useful. Then what will happen? Can I ask you, like, I don't know, tomorrow onwards, you should start understanding 100 points per hour like that if I instruct. Does it make any sense? It is not practically possible. It is not meaningful. Then what is possible? Instead of me teaching 100 points per hour, if I start teaching 10 points per hour, then the communication between you and me will be meaningful. I will be teaching 10 points per hour. You can understand 10 points per hour. Now it is okay. But the important point to be noted is, am I operating at my full efficiency? Please respond. I can teach 100 points per hour, but since you cannot understand 100 points per hour, I came down, I started teaching only 10 points per hour. Now tell me, am I operating at my full efficiency? Am I operating at my full efficiency? What is my efficiency? 100 points per hour is my capacity. How much I am teaching? 10 points per hour. So what is the percentage of my efficiency? I can teach 100 per hour, but how much I am teaching? Only 10. So what is the percentage of my efficiency? Am I being utilized fully? Yes, that's great, Jashwant. 10% is my efficiency. Similarly, what will happen here? If CPU starts interacting with these devices directly, its efficiency will also be reduced drastically. Then what is the difference if you are using a very old i3 processor or a modern i5 processor or a i7 processor? There is no difference at all. When your processor is operating at a speed of IO device, then there is no meaning if you bought a very latest modern i7 processor, or still if you are using a i3 processor, it does not make any impact, does not make any effect, because your CPUs are not at all working at their speeds. They are working very, very, very slow at a speed of a IO device. That's the reason, since there is a direct and a drastic impact on the performance of computer. No CPU will directly interact with IO devices. That's the reason this block diagram is very, very, very important, right? So coming to interrupts, we will discuss because we have to discuss CPU first, main memory. Once this part is done, I will be addressing the interrupts part also. But meanwhile, did I answer your question, Jashwant? Like why CPU does not interact with IO devices directly? Did I answer it? Is it clear and convincing? Okay, Jashwant. That's great, friends. So I hope today's session was meaningful and I could explain you what exactly is the purpose of this bridge program. Before we meet in our next class, I'll be very happy to understand from you, like because you are all new to me, I'm new to you. So our communication, our conversation should be meaningful and fruitful, right? So, in order to ensure that our conversation and communication is meaningful and fruitful, let me hear from you. You just gave a quick feedback of the session, whether you're following me or not. I just need a quick feedback. For that, what I have done is I shared a QR code on the screen. So, please scan it. It will take you to a Google form wherein you can give your feedback. So please quickly give the feedback before you leave. And I hope today's session was meaningful and thank you for attending the session. I hope tomorrow onwards all other students will also join us. Kindly give your feedback before you leave the session. Thank you. The QR code, you can scan it and you can start giving the feedback.